We're going to go over some basic reactions of alcohols and talk about the products that are formed. Some things to keep in mind before we do some actual problems is the identification of an alcohol. You have to first identify if you're dealing with a primary, secondary, or tertiary alcohol, and then think about what the products are being made for each of those. If you have a primary alcohol in the presence of an oxidizing agent, you are going to form first an aldehyde and then finally a carboxylic acid. With a secondary alcohol, that's in the presence of another oxidizing agent, you have only one carbon-hydrogen bond, so there's only a place to break one bond. You are going to have a single-step reaction and you will form a ketone. Tertiary alcohols have no open carbon-hydrogen bonds to break, and therefore, in the presence of an oxidizing agent, you get no reaction. Okay, in our first example, the first thing you'll need to do for these problems is to identify what type of alcohol you have, if it's primary, secondary, or tertiary. So I'm going to look at this carbon that is attached to my hydroxyl group, and I notice that it has two hydrogens coming off of it and one R group. So therefore, this is a primary alcohol. And we know a primary alcohol will oxidize to an aldehyde. So the first step of this reaction has us oxidizing. We're going to break one of our carbon-hydrogen bonds and form another carbon-oxygen bond. So nothing changes to the carbons on the end. But now I have a carbonyl at the end of my carbon chain, which is an aldehyde. So I go from a primary alcohol to an aldehyde, and a side product that I have is water. Primary alcohols go through a second reaction, a second oxidization to a carboxylic acid. And the reason they do this is because they have another carbon-hydrogen bond that we can break and form another carbon-oxygen bond. So if we do another reaction, I'm going to write this below because I don't have enough room to show it. You'll have CH3, CH, okay, you still have your carbonyl group, but now we've replaced our carbon-hydrogen bond with a hydroxyl, so now we have a carboxylic acid. All right, in our next example, we're going to start with the same method that we had before, and we're going to look at the carbon that is attached to the hydroxyl group. Okay, so this carbon has one hydrogen attached to it and two R groups. So therefore, this is a secondary alcohol. And we're going to see what happens when this is oxidized. And I know a secondary alcohol in the presence of an oxidizing agent will create a ketone. So we will break that carbon-hydrogen bond and we will form a second carbon-oxygen bond. So the resulting ketone looks like this. Okay, so notice that I've lost my carbon-hydrogen bond and I have formed a second carbon-oxygen bond. This cannot oxidize further. And the reason it cannot oxidize further is because I don't have any more carbon-hydrogen bonds to break. All right, let's look at this example, and the first step is always to identify what type of alcohol we have. So I'm going to look at the carbon that is attached to my hydroxyl or my alcohol group, and I notice that it has 1, 2, 3 R groups on it, no hydrogens on it. Because of that, this is a tertiary alcohol. Therefore, I have no carbon-hydrogen bonds to break and reform as a carbon-oxygen bond, so therefore, I have no reaction. All right, I just threw this one in for fun. This doesn't have to do with oxidation of alcohols, but it is a reaction of an alcohol. So here we have 1 propanol in the presence of a strong acid. This could be H2SO4, and it is being heated up, and that's how we show heat in the reaction. What happens when you have this is called a dehydration reaction. So that means that we are going to lose water, so 1 molecule of water. Okay, so I'm going to draw this out just so we can see this a little bit better. So we have C with 3 H's around it, connected to another C and another C. All right, I'm going to do the full structure here. Okay, so what's going to happen in the presence of my strong acid and heat is I'm going to remove 1 hydrogen from 1 carbon and a hydroxyl from another carbon. Now, if this were a longer chain, I would have to decide, do I take this hydrogen or do I take a further hydrogen? But because it's on the end, I don't really have a choice. I have to take this hydrogen that's right next door. So I'm going to remove 2 hydrogens and 1 oxygen, and that empty space is going to form a double bond. So what I'm left with is CH3, CH, and I've removed this hydrogen right here, so I'm going to leave just 1 hydrogen in my condensed structural formula with a double bond, and now I only have 2 hydrogens left at the end. So now I have propene rather than 1 propanol.